Welcome back to the Passages Podcast. In this very exciting episode, host Zach McMillan-Kenny dives into the importance of sediments in looking back in time in the geological past of the Canadian Arctic and subarctic. And as always, all episodes are recorded while at sea on the CCGS Amundsen during this year's Arctic expedition.
To tell you a little bit about me, I recently completed my master's degree in physical geography at Memorial University, where I mapped the seafloor habitats of Arctic char and Greenland cod in Nunatsiavut to support Indigenous research priorities. I'm a scientist passionate about the critters living on the seafloor, and I love communicating scientific efforts. On board the Amundsen, I'm assisting with mooring operations and serving as a communications coordinator for Amundsen Science, showcasing all the fascinating science being done on board. Today, I'm joined by Émilie Saulnier-Talbot, Assistant Professor at Université Laval. Hello, Emily.
Hi, Zach.
Hilary Corlett, Assistant Professor at Memorial University. Hey, Hilary.
Hey, Zach.
And Laura Broom from Natural Resource Canada and Geological Survey of Canada. Hey, Laura. Thank you so much for joining us today for the fourth episode of the Passages Podcast. Should we all get started?
Yes.
Great. First, I'd like to know a little bit more about you all. Let's start by asking an easy question to each other. So, how's your day going, Laura?
Pretty good. It's near the end now, so I'm starting to pack up. How are you, Hilary? I'm pretty good. Pretty excited to be wrapping up, but a bit sad to leave the boat, of course. And how about you, Emily? How are you this morning?
I'm fine. I'm finding it a bit rocky now. It's been smooth sailing the whole way, but now we're seeing a bit more action.
Definitely, yeah. I can feel the waves here moving back and forth in the chair. Thanks, guys, for being here. So let's dive a little deeper. Emily, you're affiliated with two departments at the Université Laval, the Department of Geography and Biology. When I began my studies in geography, I found it difficult to explain what the discipline of geography actually was to people. I'm curious if you have a good explanation for our listeners, and I wanted to know also how your research is connected to both departments, biology and geography.
You're right, Zach. It is difficult to define geography. If you look at, for example, the best-known geographic magazine in the world, National Geographic, they define what they cover as the world and all that is in it. So that's basically what geography is. It's vast, but I think most precisely, in geography, we try to answer the question, where are things happening? It can be divided into two main branches. So you mentioned that you have a degree in physical geography.
Yep.
There's also human geography, so the study of humans in their environment. My research interests also lie in physical geography, as yours, and more particularly in biogeography, which is the study of how organisms are distributed across the world, which is, I think, what you did for your master's. I specialize in the study of aquatic microorganisms that help us to better understand how ecosystems change through time and space. And this is why my research is connected to both biology and geography.
Awesome. That was a great answer. So, Hilary, you're a paleontologist. When I hear that, my immediate thought goes to dinosaurs and fossils. Could you describe a little bit about what paleontology is and what you study at Memorial University?
Sure, Zach. So I would say paleontology in general is the study of ancient life. So we look at fossils and try to figure out what type of fossil it is, what type of organism it was. There's various ways of doing this through measurements and various tools of taxonomy. I would say that paleontologists also work on modern examples because there's a saying in earth science in general that would say the principle of uniformitarianism, which is basically saying that the present is the key to the past. So a lot of the time we study modern day organisms to actually try and understand something of the organisms from the past, even if we don't have living relatives of those organisms. My work at Memorial, I teach paleontology, but for my research, I actually utilize paleontology as a tool in my carbon and sedimentology research. carbonates are sediments that are basically made up of living things. So any organisms that create or precipitate a calcium carbonate skeleton or shell, they actually break down into smaller pieces. And this is what limestone is made up of. So anybody who's ever seen a limestone building, you're basically looking at something that might have been an ocean at one time. So I look at rocks that are made up of living things. Therefore, I also study the living things and where they live, how they lived in the past.
Great. And Laura, you work with the Department of Natural Resource Canada. Could you share a little bit more about your scientific background, previous experience, and what you do at NRCan?
Yeah, so I am a marine geoscientist at the Geological Survey of Canada, which is part of Natural Resources Canada. And I have background in earth sciences and biology, and at Dalhousie University. And then I went and got my master's in marine geology as well. And that's how I ended up at Natural Resources Canada. We have in Halifax at the Bedford Institute of Oceanography, we have a big group of us that work on the marine geoscience for Canada's offshore. And there we take care of learning about the seabed all the way from the east coast of Canada, so offshore Nova Scotia, Newfoundland, Labrador, all the way into the Canadian Arctic. We also have an office on the west coast that takes care of offshore British Columbia.
Great. Yeah, so it seems like you all could have worked in various fields all over the globe. So what brought you to work in the Arctic and in the Arctic Ocean? We'll start with you, Emily.
I did my graduate research at the Centre d'études nordiques at Université Laval. It's one of the oldest coal systems research institutes in Canada. And I worked on projects in coastal regions of Nunavik in northern Quebec. So for my master's and my PhD. And then I also served as a scientific coordinator for the Centre d'études nordiques. And I was a research associate at University of Alaska Fairbanks for several years. So the North is something that really strikes a chord with me, interests me a lot, even though I have also worked in other types of environments, in tropical environments and temperate environments as well. My background is anchored in limnology, so that's the study of lakes and freshwater ecosystems, but many of the research projects that I participated in dealt with coastal lakes. So eventually the jump to the other side of the coast, the marine realm, came naturally when the opportunity arose.
Wow. Yeah, I always find the call to the Arctic is very strong. At least for my master's, I've loved being up there in Nunatsiavut, and yeah, going further north is always fun. And so for you, Hillary?
For myself, a couple of reasons. I would say, number one, I just recently moved to Newfoundland and Labrador from Alberta. And so not being surrounded by ocean for quite some time. Now living in Newfoundland, I'm surrounded by ocean, and I feel that every day in Newfoundland, it just feels like it's the cycles of kind of what even goes on in town are linked very closely to the cycles of the ocean. It's a place that you feel it every day. And I just feel that I'd like to try and contribute to a better understanding of how this environment is changing, especially right now, and how it'll change over the next several decades. I would also say that in the sedimentary record, in my own research in carbonates, but also in siliciclastic sediments, there is a bit of a skew towards studying more in southern and more temperate regions, and there's less done in Arctic environments. So from a contribution to science standpoint, I think that's another reason why I'm quite drawn to working up north. And I really like the idea of the work that we're doing as part of the project that I'm here working on, because we're actually going to be looking at latitudinal gradients in this project, which I'll talk a little bit more about later. But just the idea that as things change and shift with climate, we might expect different things. But looking at the geological record in these areas, we can use the past to try and help predict a little bit more about the future.
The Arctic and the Arctic Ocean are very remote areas, but infrastructure like the CCGS Amundsen provides a unique opportunity for field studies. Laura, I heard you were here last year on a similar leg of the expedition. How many times have you been on the Amundsen, and why are you a part of this leg instead of one going further north?
So this is my 6th time on the Amundsen,
Wow.
which I feel very lucky. I started coming on the Amundsen as a fresh hire in 2019, and we've had the opportunity to come back ever since. So it's been really awesome, and every year it's been a different and a great experience. So we came on this expedition this year because it started on the Labrador coast in Nunatsiavut, and then is ending now in southern Baffin Island, Kitarjuak area. And so we were really interested in both those regions for some of our programs. We've been working closely with the Nunatsiavut government. They're doing a map of Nunatsiavut Marine Plan, and our work is going to contribute towards that. We are looking at the marine geohazards across the fjords in northern Labrador. So we were there for the first half of our trip, taking samples from Okak Bay and Nafak Fjord, trying to understand the history of submarine landslides in those regions. And luckily, on the second half of this trip, it's also worked out that we are collecting samples in a few Arctic fjords, one which we have had the chance to be in before, Coronation Fjord. And this will link to work we're doing on the geohazards near northern communities. So this ties into work we've done in Pond Inlet, Pangertung Fjord, and now Kitarjuak.
Wow, cool. Emily, as an associate professor at Université Laval, how long have you known about the CCGS Amundsen and its activities?
Well, because the Amundsen is a project that was initiated by professors at Laval when I was a graduate student. I've always been familiar with the activities going on the Amundsen ever since it began. However, this is my first trip aboard. So as an undergraduate student, I had the chance to participate in another scientific cruise aboard another Coast Guard ship called the Hudson, which is now retired. So this is my second experience aboard a scientific cruise, but the first on a ship that's totally dedicated to science. And it's very stimulating to be here. It's lots of fun to see all the work that's being done 24 hours a day, 7 days a week. We never stop. So a lot of data is being collected, which is great because that's what we need more of.
Yeah, there's definitely a lot going on all the time here, which is great to see. Hilary, how many times have you been on board the Icebreaker, and have you known about its operations for a while as well?
I have never been on the Amundsen or any coastal research vessel, so I'm a total newbie. It's amazing to see all of the research that goes on these vessels. I can't believe the pace that people keep up and just the smooth way that things have operated between operations. It's incredible to see. We throw in a whole bunch of different nets and then later we're coring, and then we're sampling water, and everybody's taking shifts and cooperating. And I just think the way that it works all together as scientists, it's really neat for us to be able to come together and see how other scientists do their work, and then also to try and contribute to the samples that we're collecting alongside people who are really used to working in these situations, like Laura and her team who've been helping us with coring. Just learning from them has been wonderful. So
that's really great.
Let me do things.
Yeah. The Amundsen is quite a unique research vessel. How do you think it's impacted your guys' work? I guess I'll start with Emily.
Well, as I was saying, everything is just organized here so that we can get on with our work. And for me, it's allowed me to sample in areas that I wouldn't be able to visit otherwise, such as the fjords. And these areas that would be difficult to sample for me if I wasn't on such a large research vessel with the capacities that the Amundsen has, with the specialized equipment, the specialized technician, all the help we have on board. This is a very, very important opportunity for my research because I'm normally limited to smaller sampling, so on smaller boats or even by foot.
Oh, really?
Yeah. So this is it's a different scale, let's say. So I'm curious to see what we've collected.
Perfect.
Me too.
Yeah. Within Natural Resource Canada, Laura, you work with a program called Geological Survey of Canada. Can you explain a little bit about what this program generally aims to do?
Yeah, so the Geological Survey of Canada is an institution that's been around since before Canada existed. So it's, it's got its legacy. And so there's a few different things that the Geological Survey is interested in providing to Canadians. So we want to, provide the basic baseline data that anyone using the seabed might be interested in learning about. So we do a lot of superficial geology mapping and understanding what the seafloor is composed of. This is important for any type of infrastructure that might get developed on the seabed or any marine protected area that might be established, because the basis for any habitat, you would know from your masters, is what the sediment is on the seafloor.
True.
That we just really are trying to provide foundational data on the seabed across Canada. It's a big area. We have a huge coastline, so it's a lot. There's a lot to do, and there always will be.
That's great. How long has the Geological Survey of Canada been established or in place?
The year it was established, I wrote it down. The year the Geological Survey was established was 1842. And the programs that we work under, they're always getting renewed and refunded. And one of the programs I'm working on was the reason I got hired, and it's been around for the last 5 years and is continuing on. It's for the marine geoscience for marine spatial planning. So I'm just trying to understand the seabed for all its uses.
Awesome. On board the Amundsen, who will you be working with? Do you also collaborate with scientists within various universities like Hillary and Emily?
Yeah, so here right now I'm collaborating with these two awesome women. And on the previous leg, I was collaborating with DFO, with Barbara Nevis at DFO Newfoundland, and also with Rod Lang with the Nunavut government. And we also collaborate with Dalhousie University. There's a student on board, Haley Gieser, and her supervisor, Chris, who we collaborate with as well. So we really love these opportunities because they bring all these scientists together, and we all we need to, you go and collect one core, but there's so many different things that can be studied from that one core. So we really can combine our resources on a ship like this and get as much as we can out of that one really precious sample. These samples are hard to collect, as we discussed. They're expensive to collect. They're really hard to replicate. So it's really important that we get as much as we can out of these and collaborate with each other on board and on shore. Some of our colleagues aren't here with us, and we'll be collaborating with them as well.
This year, Emily and Hillary, you're both involved in research projects under the program called Transforming Climate Action, or TCA. Could one of you explain what this program is all about?
I can start, and Hillary, you can add on. So TCA is a major Canadian research initiative that aims to better understand the role of the ocean in climate change, because the ocean is kind of the missing factor in all the climate change models. And it's so vast and so complex that we haven't been considering it in its rightful place in these models. So we're trying to develop and better our understanding of the ocean in the context of current climate change. And TCA involves researchers from 4 universities. So there's Dalhousie, and there's Memorial in Newfoundland, and 2 universities in Quebec. So Université Laval, where I work, and Université du Québec à Rimouski. And we also, within TCA, are collaborating with communities and the private and public sectors as well. And it's going to run for the next 6 years. So we have funding for a few years and trying to get our understanding of the ocean and its role in climate change to a better level. Yeah.
That's great. Did you have anything to add, Hillary?
I'll just add that I guess one of the main focuses for the scientific portion of collecting data and whatnot in the TCA is that we are trying to reduce our uncertainty with respect to the exchanges within the carbon cycle that take place in the ocean and how that may be affected by climate change, what the role is presently and in the past in terms of uptake of CO2 and sequestration, possibly long-term sequestration of CO2, to evaluate whether or not that could be affected by changes in climate, and basically trying to just understand the various exchanges between air and sea, the water column and the sediment, and also between land and sea and the sediments in the sea, to try and figure out basically how those exchanges affect these overall carbon uptake and sequestration of CO2.
Very cool. And so what are your expectations for the expedition, Emily?
Well, our expectations have been met, actually. We were able to collect sediment cores from 3 fjords, as Laura mentioned before, and the 3 fjords that we had targeted near Qikiqtarjuaq. And so it was a successful mission. And in my case, I was also hoping to initiate some of my research students to this type of research. And that was also successful as I was accompanied by 2 students who will be starting graduate programs next January. So they actually got a chance to see what life on board a research vessel is, and they got to sample some of the cores that they will be working on for their master's and PhD. So that was really important to me, because when you do research and you get your own samples and get to see the environment that you're studying, is really precious.
Yeah.
So I'm really thankful that they got this opportunity.
Yeah, it's definitely key. I'll speak from experience. 2 weeks into my master's, I was thrown on a boat and to collect fieldwork. So yeah, it definitely helped get me in gear for what the master's would then follow up to be. So Hillary, did you also meet your expectations on the Amundsen?
Yes, I'm extremely pleased with what's gone on the Amundsen. In terms of sample collection, we have a good collection across the 3 fjords, and we were actually able to sample also at the mouth of the fjords and then into deeper water. So for myself, studying the transport of material from terrestrial environment into the ocean and then from shallow water environments into deep water environments, that was really exciting to be able to collect those cores across the transect. And for myself as well, in my research program, I'm hoping to recruit 2 students who I want to send out on research vessels. And since I had never been on one myself, it was something I'd really hoped to do so that I could describe what they'd be doing and sort of describe what a normal day would be like, and what expectations to have, how to successfully sample, label their samples. Labeling's important.
Yeah.
And package it up and basically have it properly documented for their future research projects. So I think coming on board and seeing how it all worked out myself, I feel a lot more capable of training students and also knowing what their research projects are going to look like based on the samples that we collect and how we collect them, what kind of material they're going to be getting. So I'm really excited about what we collected and about the work and training of new students.
That's awesome.
Can I say an anecdote?
Yeah.
So this, when I got hired at the Geological Survey, this was the first vessel they sent me on in 2019. And I'd been on one cruise as a student. I was a little baby then, didn't know up from down. And so Alex Normandeau says, you want to go on this research vessel. It's going through your master's area that you've never seen, which is Pond Inlet. It's a month at sea. And I was like, heck yeah. Yes, please. And so I came on, and as you said, it was a crash course because it was just me and one other team member. And Alex was a chief scientist, so he's taking opportunities as they come. Any spare moment, let's put the core down. I got questions I want answered. So we're putting the core down, we're bringing it up, we're pulling the pieces out. And I had never done that on my own, and I had never, done it on the Amundsen. And so, yeah, it was, you learned quick. 24 hours, 48 hours, you were a coring specialist, whether you wanted to be or not. Yeah. And we came into Coronation Fjord that year, and never in a million years did I think I'd be here in 2024 coming back to Coronation Fjord. It is such an amazing place, and I feel so lucky to get to come on the Amundsen and get to see places like that.
Yeah, it was so beautiful.
It
Definitely was, yeah.
Yeah, amazing.
Awesome.
And we've seen quite a bit of ice since it's an icebreaker.
Yeah.
It's a kind of necessary thing to have.
True. So, since you work with the TCA, are you, Emily and Hillary, are you guys both working together on specific projects? And were there operations aboard the Amundsen that you guys were collaborating?
Yes, we did everything together. The cores we're collecting, we'll both be working on, as well as with other colleagues. So one core will go a long way. It's a lot of sediment. The diameter of the tubes is about 10 centimeters, and we've collected 3 long gravity cores, one in each fjord, and many surface samples, many surface cores from transects from the head of the fjords to the ocean. So yeah, we're all working. Our group in TCA is working on all the same samples with different approaches. For example, I'm looking at the accumulation of phytoplankton in the cores, so to see changes in ocean primary production. So looking at the differences in different types of fjords. So the 3 fjords that we cored, one of them has a glacier, one of them had a glacier not long ago, and the other one doesn't. So those are 3 different types of fjords that we find in the Canadian Arctic, and we want to see if there are different differences in those different types of fjords. Do some types of fjords accumulate more carbon than others? And how does that vary over time? And we want to look at timescales going from the last few centuries to the entire post-glacial, if we can, depending on what we've collected. We won't have an idea until we get them dated. So
cool. In order to collect these samples, you mentioned a lot of cores. So you were using box cores, right? Are there other operations that you were doing, and how did they work? How do they sort of work?
Well, Laura's the expert here.
Sure.
We're happy to speak to them. Yeah. So there was 2 main coring operations that we utilized on this trip. When we want to get the surface of the seabed, we use a box core. It's more shallow. It takes, I don't know, at best half a meter of sediment from the seafloor, and when that comes up, you can tell, especially if there's a bit of water on top, that you've gotten a nice surface sample of the seabed. And then we take tubes and we push them into the sediment, and that's how we collect our cores. So that'll give us, hundreds of years in the past, that sediment. And then we want to connect that to the deeper past, so we use gravity cores. So these are long tubes. We put together 9 meters of metal barrels with a huge core head on top that weighs many thousands of pounds. And we put that over, we put liner inside, and we put that over the side of the ship, and it slams through the sea floor and collects meters of mud. I think our best sample was over 6 meters of mud, of sediment.
7 meters.
Yeah, 7 meters. Wow. We did great. And so this will give us the deeper past. So this will give us tens of thousands of years of history if we're lucky. And as Emily said, once we know how old it is, once we date it. Yeah.
Wow. That's a lot of mud for sure.
Yeah.
Cool.
Yeah. And I'll just pipe up here to say that the sediment that we collected, Emily mentioned this already a little bit, but We have other researchers involved with our group, and so the sediment cores that we collected are actually going to be split and sent to 6 different researchers who all have students they're training. So the material that we collected here goes a long, long way in terms of research capabilities and
Lots of different projects.
Lots of different projects, lots of training students how to work on these things. So it's just, it will make a big impact, let's say, not just on us.
And we utilize all the tools on the ship. So at the same time the cores were being collected, we also collected multi-beam bathymetry data. So that shows us the morphology of the seafloor. And 2 of these fjords didn't have this data collected in it before. So it's going to give us completely new insights into what the seafloor looks like in these areas, which is unique and a great opportunity for us.
Yeah, that is a great opportunity for sure. We hope you found today's discussion as enlightening and exciting as we did. Stay tuned for the next episode of Passages, where we'll continue to explore the remarkable science happening in the Arctic. Cheers, everyone.
Thank you again to Zach for hosting this week's episode. If you have any questions for any of the speakers today, feel free to reach out to Amundsen Science at media@as.ulaval.ca. We'll see you in the next one.